Hello everyone, welcome to the 20th video of our lecture series. In the previous video, we have talked about time-dependent perturbation theory, and in this video, so before proceeding with this sinusoidal perturbation, so let us try to solve some problems regarding this time-dependent perturbation theory. So these problems are from the famous book written by David J. Griffiths. So you will find problems there. So let us proceed with our first problem. So this problem states that you don't assume HAA bar and HBB bar to be zero. So in the previous video, while we were discussing about time-dependent perturbation theory, so we generally what we have assumed, we have assumed that the diagonal terms, they belong to zero. But if we don't assume then to be zero, then we have to find first CAT and CBT in first order perturbation theory. So, and what are the initial condition? Our initial condition is that CA0 is 1 and CB0 is 0. That means initially our system is in the ground state. So then we have to calculate the ground state probability after a time t, and first and the upper state coefficient after time t, and we have to show that like the total probability should be 1 to the first order in H prime. So let us proceed with our first problem. So from the previous video, we can tell that our CA prime t is minus I by H cut, and here we have CA H AA prime plus CB H AB prime e to the power minus I omega 0 t, and our CB prime is minus I by H cut CB HBB prime and CA HBA prime e to the power I omega 0 t. So these are our standard result that we have got in our previous video. So, and here we are given with our initial condition CA0, that means CA at time 0 is 1 and CB at time 0 is 0. So we have to calculate first order. So for that, what we should do? So first we will calculate the zeroth order coefficient and we will insert them in the coefficient of this CA dot and CB dot. So let us proceed. So zeroth order. So in zeroth order, CA0 so this is 1 and CB at any time in zeroth order should be 0, because zeroth order means we don't have any perturbation, and if we don't have any perturbation, the system will remain in the state in which it was initially. So no matter after how many time you observe, the system will always be in the ground state. To allow transition, there should be a perturbation which is time dependent. But in zeroth order, that means we have lambda to be 0, and in the system there is no time dependent potential or time dependent part of the Hamiltonian is not present. So that is why at any time the system will remain in the state where it is initially. So we have CAT to be 1 and CBT to be 0. So now proceed to first order. So for first order, we will insert these values here. So what will be our CAT? So CA at any time in first order will be minus I by H cut CAT in zeroth order HAA plus CB zeroth order at any time HAB prime e to the power minus I omega 0 t. So it will give us I by H cut. So this term is 0. So we will left with minus I by H cut HAA prime. So what will be our CAT1? So CAT in first order correction will be minus I by H cut HAA prime T bar dt prime. So we will have to integrate this. And what will be the integration time? It will be from 0 to t, and we will have our initial condition. So since the system is initially in the state 1, so we will have 1 here. And what will be the CBT? So CBT derivative in first order will be minus I by H cut. Here we have CBT at time 0 HBB prime plus CAT in zeroth order HBA prime e to the power I omega 0 t. So here this term will give us 0. So we will have CBT in first order to be minus I by H cut integration from 0 to t, and here we have HBA prime at time t dashed e to the power I omega 0 t dashed and dt dashed. So this is our coefficient in first order at any later time. So we have to now verify that this the summation of the square of these two terms will be 1. So let us proceed. So for that we have to calculate CAT. So up to first order, what will be our CAT? Up to first order, our CAT is 1 minus I by H cut, and here we have HAA prime T prime dt prime from 0 to t, and up to first order our CBT is minus I by H cut 0 to t HBA prime T prime e to the power I omega 0 t prime dt prime. So you have to show that CA and CB square of them is 1. So you have to show this. So what will be CAT squared? So CAT squared, it will be 1 minus I by H cut H AA prime T prime dt prime, and integration is from 0 to t, and another term we will have the complex conjugate one. So it will be 1 plus I by H cut from 0 to t H. Since this H is Hermitian, so we will have the same term here dt prime. So it will give us 1, and another term will be 1 by H cut integration from 0 to t HAA prime T prime dt prime. So square of this. And the other two terms will cancel out. Now, since this squared represent the probability, so it can't be greater than 1. So this term must be 0, and we have our CAT squared to be 1. So now if we calculate CBT squared, so we will have minus I by h cut 0 to t h b a prime t prime e to the power I omega 0 t prime dt prime, and we will have another term to be I by h cut 0 to t h b a prime t prime e to the power minus I omega 0 t prime dt prime. So this term will give us 0. So if we calculate the CAT squared plus CBT squared, so it will give us 1. So this is like trivial. If you do it calculation, you will get easily this to be 0, and we are done with our first part of the problem. So now let us proceed with the second part. So we are assuming this. So we are given two quantity dA and dB, which are defined in this way. So we have to show that their time evolution or time derivative follows these two equation. So, and while this phi, it is given like this. So let us proceed. So we have dA to be e to the power I by h cut 0 to t h a prime t prime dt prime ca, and dB to be e to the power I by h cut 0 to t h bb prime t prime dt prime, and here we have CB. So what will be our dA prime? So dA prime will be so just do the calculation 0 to t So this is our dA prime, but we know that CA prime is minus I by h cut CA HAA prime plus CB HAB prime e to the power minus I omega 0 t. So if we plug this here, so we will get dA prime to be minus I by h cut to the power h cut to t So what we are doing, we are just plugging this CA prime, we are replacing this by this, and if we observe carefully that this CAHA prime and this CAHA prime, these two term will cancel out, so we are only left with one term in dA prime, which consists of this part. So we have this, and we have our like this exponential factor here. So this is our dA prime. So but we know that again CB is e to the power. So since dA is this, and dB is this. So we can replace CB with dB. So CB is basically e to the power minus I by h cut 0 to t h bb prime t prime dt prime dB. So if we replace that here in CB, so we will end up with dA prime to be minus I by h cut e to the power I by h cut 0 to t h a prime t prime dt prime. So this is we have, and we are replacing this CB with our given quantity. So after replacing, we will get here minus h bb prime t prime dt prime. So let me just check once. Yeah, and we have here h a b prime e to the power minus I omega 0 to t dB. So we have dA prime to be minus I by h cut e to the power I phi, because in our given problem phi is defined as this. So we are replacing our this term, this whole term, this with phi. So we have it minus I by h cut e to the power I phi h a b prime e to the power minus I omega 0 to t dB. So this is our dA prime. Similarly, we in the similar procedure we will approach and we will find the time derivative of dB. So let us do. So dB prime will be e to the power I by h cut 0 to t h bb prime t prime dt prime. We have here I by h cut h bb prime cb, and another term will be I by h cut 0 to t h bb prime t prime dt prime and cb dot. But cb, now similarly we will replace this cb dot. So cb dot is minus I by h cut cb h bb prime plus ca h ba prime e to the power I omega 0 t. So it will give us basically so if we replace this here, so we will have our dB prime to be minus I by h cut e to the power I by h cut 0 to t h prime bb t prime dt prime ca h ba prime e to the power I omega 0 t. Now again we can replace this ca by dA, and ca will be I by h cut 0 to t h prime aa t prime dt prime and dA we have. So we will get dB prime to be minus I by h cut e to the power I by h cut integration from 0 to t h bb prime t prime minus h aa prime t prime dt prime, and we have other terms like h ba prime e to the power I omega 0 t dA. So again we can replace this by phi, and we will have minus I by h cut e to the power minus I phi and other terms. So h ba prime e to the power I omega 0 t dA. So hence proved. So we are done with our second problem. Second part of the problem. Now we have to proceed with the third part. So what you have to do, use the method in part B, that to obtain CAT and CBT in first order perturbation theory, and we have to compare our result to our answer A. So let us proceed. So our initial condition is CA0 is 1. So that will imply so that will imply our DA0 to be 1 and CB0 is 0. So that will imply our DB0 to be 0. So in the 0th order, what we will have? In 0th order, we will have the same values. So 0th order, DA at any time will be 1 and DB at any time will be 0. So what will be in first order? So in first order, we have our DA prime to be 0. That means our DAT, it will be 1. And since DAT is 1, so what will be our CA? Our CAT will be e to the power minus I by h cut 0 to t h a prime t prime dt prime. So how can we say this dA prime to be 0? Because dA prime we have in this form. So dA prime is given by this, and since this is 0, so we will have our dA prime to be 0 in first order. So and what will be dB prime in first order? So dB prime will be minus I by h cut e to the power minus I phi h b a prime e to the power I omega 0 t, and we will have dA which is 1 in first order. So we have to multiply this with 1. So our dB will be so this is our dB, and from dB we can calculate our CB. So CBT will be minus I by h cut e to the power minus I by h cut 0 to t hbb prime t prime dt prime, and we have 0 to t e to the power minus I phi t prime hba prime t prime e to the power I omega 0 t prime dt prime. So so we have to comment on if there is any discrepancies or not. So if we look carefully that our result in A and result in C, they doesn't look exactly similar, but you have to remember that we are working only to the first order in H prime. So in up to first order, our CAT we can be this can be written as 1 minus, because CAT we are given with this. So in first order we can write as I by h cut 0 to t h a prime t prime dt prime, while for CB the factor hba in the integral means that it is already first order, and hence both the exponential factor in front and e to the power minus I phi, it should be replaced by 1. Then if we do this, then our CBT, it will be almost minus I by h cut 0 to t hba prime t prime e to the power I omega 0 t prime dt prime. So what we have done, so here for this we make notice that hba in the integral means it is already first order, and hence both the exponential factor in front and e to the power minus I5. So hence both the they should be replaced by 1. If we do this, then we have our CB prime to be this, and so this is exactly the result what we have obtained in our first part. So this is it for the first problem. Now we will move with our second problem. Okay, so now let us move to the second problem. So here we have to solve equation 913. That means our that CA and CB up to second order. So for the general case, so while deriving 930, we have assumed that our CA at time t equal to 0 is 1 and CB at time t equal to 0 to be 0. So that means we have two states and system is initially in this state. So suppose it has energy EA and energy EB. So for that case we solved. Now we have to solve that system is not in this state or in this state, but in a linear combination. That means it has a finite probability. So it has probability A square to be in this state, and it has probability B square to be in that state. So for this case, for linear combination of these two states, the initial state is a linear combination, and for that case we have to find how their probabilities, like probability of finding the whatever particle or system in this state at a later time in second order, and the probability of the system to find in this state at a later time up to second order. So that we have to now calculate. So since this is our initial condition is now CA0 is A and CB0 is B. So we have to find second order. That means first we have to find zeroth order, then first order, and we will insert first order to find the second order. So in zeroth order, so zeroth order means no perturbation. So probabilities will not change. That means CAT will be A and CBT will be B. Now we have to find in first order. And while deriving that 930, we have assumed that HAA prime and HBB prime to be 0. So we will still assume this, that this diagonal term will vanish. So if we assume this, then our CA derivative at t will be minus I by h cut HAB prime e to the power minus I omega 0 t b. And so from this we will get CA in first order at a time will be A. So this is zeroth order, and we have minus I B by h cut 0 to t HAB prime t prime e to the power minus I omega 0 t prime dt prime. And CB, what will be a CB prime, CB derivative? CB derivative, it will be minus I by h cut HBA prime e to the power I omega 0 t A. So what will be our CB in first order? So CBT in first order, it will be B minus IA by H cut 0 to T HBA prime T prime e to the power I omega 0 T prime dt prime. So we have found out our CAT and CBT in first order. So we have to just insert this in to find our second order. So in second order, CA prime T will be minus I by H cut HAB prime e to the power I omega 0 T, and here we will insert our value of CBT1. So it is B minus IA by H cut 0 to T HBA prime T prime e to the power I omega 0 T prime dt prime. So from this we will get our CA at any time up to second order as A minus IB by H cut 0 to T H AB prime T prime to the power minus I omega 0 T prime dt prime. So that is first order, zeroth order, that is first order, and another term will be A by H cut squared 0 to T HAB prime T prime e to the power minus I omega 0 T prime, and we will have a multiplicative term here which will be 0 to T prime HBA prime T double prime e to the power I omega 0 T double prime D double T prime, and we have dt prime. So this is our desired result, like CAT up to second order at any time. So now we have to find this CB. So to find CB, we have to just do the two following things. We have to switch A to B, and we have to change the sign of omega 0. So if we do these two things, then we will end up CB2T to be B minus IA by H cut 0 to T HBA prime T prime e to the power I omega 0 T prime dt prime, and we have our second order term to be B by H cut squared 0 to T HBA prime T prime e to the power I omega 0 T prime, and it will be multiplied with another term 0 to T prime HAB prime T double prime e to the power minus I omega 0 T double prime dt double prime, and here we have dt prime. So this is our change, this is our CB to T. So we have our result. Like we start our equation 13, and we assume that our initial state is a linear combination. So for that case, we have found our value of this coefficient at any later time up to second order using this perturbation theory and successive analysis. So that is it for today's video. So in the upcoming video I will discuss some more problem, and then we'll discuss the sinusoidal perturbation case. So we will meet on our next lecture video.